welcome back to Global Education Zone. And today, in this particular episode of our introductory, or rather secondary school mathematics class, we'll be dealing with equations and formulas. Now, we did a part 1 of equations, algebraic processes, right? Now, this is the part 2 of algebraic processes, and in this part, we'll be dealing with how you can solve algebraic equations and how you can solve algebraic formulas. So now, there are different methods we'll be dealing with in this video. So the first method we'll be dealing with is the solving by linear equation. So solving linear equations. So today the first technique we'll be using for our algebraic equations is the technique of solving linear equations. So we'll solve linear equations first in our algebraic processes. So to solve a linear equation, most often you will often be given unknowns as terms, and then you have constants. Your constants are your number from 1, 2, 3, 4, 5, 6, and then your unknowns are your alphabets, like your X, your Y, your Z, your A, your B, and your C. Now, the aim of an algebraic or a linear equation is to solve for your unknown, which is your alphabet. And your alphabets usually have numbers with them, and those numbers are called coefficients. Now, this number 1 plus 2x is equals to 3. Now, in this particular equation, this is a linear equation because the highest powers of the unknown is 1. So, if the highest power of the unknown is 2, it's called a quadratic equation, Then, if the highest power of the unknown is 3, it's called a cubic equation. Now, for this particular type of equation, this is your constant. Your 1 is your constant. Then your x is your unknown. Then your x is also known as a variable. Your x is a variable. Now, this x as a variable also has a coefficient. Now, the coefficient of x, the coefficient is the number that is multiplying your variable. Your coefficient could be a constant like 2. It could also be another variable. So now, what you do in equations is you solve for your variables. So now we are looking for this x. What you solve for is a variable. The first thing you do is you collect like terms. You collect the numbers together and you collect the variables together. Now, this is the only variable, so we can leave it here. But there is one constant here and there is one constant here. So we should collect the constants together on the right hand side of the equation. So we can do that by subtracting the constant from both sides of the equation. So when we do that, we will be eliminating the constant on the left hand side here. So this will have 1 plus 2x is equals to 3. So these are equation. I've spaced it out now. So the next thing we'll do is we'll subtract our constant. So minus 1. Subtract our constant from both sides of the equation. So 1 minus 1 will be 0. That will leave 2x on the left hand side of the equation. And on the right hand side of the equation, we have 3 minus 1. That is 2. Now 2x is equals to 2, right? So we divide both sides of the equation by 2. 2 cancels 2. So we have x left on the left hand side. Then we have on the right hand side, we have 2 over 2 is equals to 1. So that is the first method of solving a linear equation. Now I'll move on to the next example of solving linear equations. Now the next example I'll be giving today is 4 minus 4x is equals to 9 minus 12x. So let's write it down in mathematical symbols. 4 minus 4x is equals to 9 minus 12x. Now this is a linear equation and we have to solve for the unknown. Our unknown is x. So we are solving for the variable, which is x, and the unknowns are the ones having alphabets. Now when you are solving linear equations, the first step is to collect like terms and group them together. That's the first step. Then the second step is to simplify. So let's take the first step. Let's collect the like terms together. What that means is that you often collect your unknowns, your variables, to the left hand side of the equation, and this is the left hand side of the equation. These two terms are the left hand side of the equation, and these two terms here, they are the right hand side of the equation. Now you collect your unknown on the left, and then you collect your constants on the right. Your unknowns are the terms that have an x behind them. The terms that have an x in front of them, these ones, we'll collect them to the other side. So what we'll do, when we move a term to the other side of an equation, it changes its sign. So when we change minus 12x to the left hand side of the equation, it changes to plus 12x. So we'll add it to the terms there. 4 minus 4x. So this minus 12x is coming to meet them on the left hand side. That will be plus 4x. Plus 12x equals 9 minus 4. So now we've moved 4 to the other side of the equation. When we move 4 to the other side, it changes to minus 4. So when you move a constant or a variable to an opposite side of an equation, it changes its sign. Now we have the like terms together. We have 4x plus 12x equals 9 minus 4. Now the next step we'll do is simplification. We'll simplify this question. So 4x plus 12x is what? If you want to add variables, all you simply need to do is to add their constants and then add the variable in front of your answer. Now let's just add the constants or the coefficients. Now the coefficient of x is 4 here, and the coefficient of x is 12 here. So we add the coefficients. That's 4 plus 12. 4 plus 12 will give us 16. Then we'll now add the variable behind that number. That's 16x equals. Then now 9 minus 4, these are constants, so we just simplify them directly. 9 minus 4 is 5. So that would be our answer for this. Now 16x plus is equal to 5. We are not really done here. The next step we have to do here is I have made a mistake in these equations because I've mistook the sign of x. So I've given x the wrong sign. Let me change the sign back. It's supposed to be minus 4x plus 12x is equals to 9 minus 4. So minus 4x plus 12x, that also means whenever you have terms that have your minus in front of your plus, you can change it and reverse it. So instead of taking the minus first, you can take the plus first. So instead of saying minus 4x plus 12x, here we will say 12x minus 4x. We'll say plus 12x minus 4x equals 9 minus 4 is 5. So 12x minus 4x, that would be 8. 8x equals 5. Now, at this stage of our equation, we have the coefficient of x. Now, we are looking for x. So when you are solving for x, you divide both sides of the equation by that coefficient in order to read that your variable of the coefficient. You want to read your variable of the coefficient. What you in essence, you want to remove the variable from the coefficient. So you are going to divide both sides by that same coefficient. Now the coefficient here is 8, right? We'll divide both sides by 8. You can also write it at the side of the equation. You can describe what you are doing. So it makes it easier for whoever is marking your work to understand. So you can write it beside it. Divide divid, divide both sides by 8. So it makes it easier to see your work and understand what steps you are taking. Now, when we divide both sides by 8, in the left hand side, 8 will cancel 8 out. That will leave us x equals 5 over 8. So that would be the answer of our equation here. Now, that is the first method of algebraic processes, is solving linear equation. Now, the next method of algebraic processes we'll be doing is to solve equations with brackets. Now, some equations, they don't have their terms lined up like this. Some of them have their terms enclosed in brackets. So how do we solve those? So that's what we want to do now. So I'll give an example, but before that, let's talk about the steps to take. Now, when you are asked to solve an equation with brackets, the first thing you do is you are going to remove the brackets before you collect like terms. Now, how do we remove the brackets? How you remove the brackets is that you are going to any coefficient of the bracket, you are going to use the coefficient of the bracket to simplify the bracket. That is what is called removing the bracket. For example, if you have a bracket and you have two terms, 2 minus 3, and in front of that bracket you have a coefficient of 2. So what this means is that when I say remove the bracket, what they are asking you to do is you are going to use that coefficient outside the bracket to simplify every single term in the bracket. So that is how you remove the bracket, and that is the first step you take when you see any algebraic equation or algebraic expression that has a bracket. Now let's do that. You are going to multiply. What is the relationship between that coefficient and the bracket? So if it is a multiplication relationship, so you are going to multiply each term by that multiplication. So that is 2 times 2 for the first term. That will give us 4. Then we'll now put the minus. Now say 2 again times 3, that's 6. So we have successfully removed the brackets. That will be 4 minus 6. And then we'll proceed again to simplify. 4 minus 6 is minus 2. Because whenever a bigger number is having a negative sign, your answer is always negative. So don't forget that. Now moving on, let's move on to a sample equation of solving with brackets. Let's solve equations with brackets. So I'll give an example. My example here will be 3 open bracket 4c minus 7 close bracket. 3 open bracket 4c minus 7 close bracket equals, equals 4 open bracket 4c minus 1 equals 4 open bracket 4c minus 1. Okay, good. Now the first thing we are going to do here is we are going to open our bracket. Let's open the left hand side bracket and let's open the right hand side bracket. And I mentioned earlier that to open your bracket, you first have to expand. So what that means is you are going to multiply every term in the bracket by the term that outside the bracket, and that term outside the bracket is also known as a coefficient. So we are going to use the coefficient to multiply every term within the bracket. So now the coefficient in the left hand side is 3, right? So we are going to use this 3 to multiply every single term in this bracket. So let's start that. 3 multiplied by the first term is 3 times 4c, that will be 12c. Then the sign is minus. Then 3 times 7 is what? 21. That's we've successfully opened the bracket in the left hand side. Let's move on to the right hand side. Equals 4 open bracket 4c, that's 4 times 4c, that's 16c. Then 4, let's put the middle sign minus. 4 times 1 is 4. So we've taken the first step of simplifying algebraic expressions or algebraic equations that contain brackets. Now the next step of simplifying algebraic equations with brackets is to simplify. Now, how do we simplify? We simplify by collecting like terms first. So you have to collect the like terms, that is the terms that have variables and the terms that do not have variables. You collect the variables together on one side of the equation, then you collect the constants on another side of the equation. Now, what are our variables here? Our variables here are 12c and 16c. So I want to collect both of them on the left hand side of the equation. So we just choose the left hand side. You can decide to collect them on the right hand side of the equation. So in this equation, let's decide to collect them on the right hand side. So we'll move these over to the right hand side, and when we move an algebraic term to an opposite side of the equation, it also changes its sign. So here we have 12c, which is also plus 12c. Then when we move to the other right side of the equation, it changes to minus 12c. That will be equals minus 12c. Then we still have the 16c on the left hand side of the equation. Then this minus 4 on the right hand side of the equation will change it to the left. That will change to plus 4. So plus 4. And then we still have our minus 21 on the left hand side of the equation. So we are good to go. Now, after collecting our like terms, the next step to do is to simplify. So we are going to simplify our terms here. In the left hand side, we have plus 4 minus 21. That will be plus 4 minus 21. Now, you know that when I said the biggest term, whenever the bigger term in a simplification has a negative, your answer is going to be negative. So this will be 4 minus 21. That would be minus 17. That's minus 17. Then on our right hand side of the equation, we have minus 12 plus 16c. That's also the same thing as plus 16c minus 12. So when you reverse the sign on the same side of the equation, when you reverse the terms without reversing the side, you are still correct. You are not wrong, you are correct. So instead of saying 12 minus 12c plus 16c, we can say plus 16c minus 12c. So 16c minus 12c, that will be 4c. So we are good to go. Now the next step to take is to divide both sides of the equation by the coefficient of your variable. So divide both sides by the coefficient of our variable, which is 4. Divide both sides by 4. So the coefficient will cancel out on the variable, and that will leave the variable on the right hand side equals minus 17 over 4. So that is how we solve equations like this. So I hope you understand that. Now, let's move on to the next algebraic process. The next algebraic process we'll be dealing with is solving equations with fractions. Now, how do you solve equations with fractions? They might look challenging at first, but they are actually simple if you understand the steps. Now, the steps are, the first step you take is to clear out your fraction. And how do you clear out your fraction? You clear out your fraction by multiplying through with your lowest common multiple. What is the lowest common multiple? The lowest common multiple is simply that term that is the lowest term that can be multiplied or that can be divided by each of your denominators. So in simple terms, your lowest common multiple is, if I have two terms in a fraction, if I have 2 over 5 minus 3 over 2. The first step into simplifying this fraction is to look for our lowest common multiple. Before we can clear the fraction, let's put equals to equals. So this is the first step. Put equals and draw a long dash at the middle point. Now we are looking for the LCM of these two. The LCM is simply that number that is the lowest number that can be divided without a remainder by each of the denominators. So what in simple terms, what I'm trying to say is that all these numbers down are called denominators, and the lowest number that they can divide is your LCM. That's why it's called the lowest common multiple. Now let's look for the lowest common multiple here. So you draw a vertical line with a horizontal bar. So if you don't know this method, you can check the earlier episodes of this series, this mathematics for high school, and I've covered something like this there. Now let's put the numbers. Let's put the number 5. Let's put the numbers 5 on one side, then let's put number 2 on another side. Let's roll another line. Now these two numbers, we are going to look for numbers. We are going to look for a number that can divide them without a remainder. So what can divide 5? 5 is a prime number, so only 5 and 1 can divide 5. Let's choose 5. 5 can divide 5, we'll give 1. So can 5 divide 2? No. So we'll put 2 down and look for another number. So 2 will be on the waiting queue, waiting for its number, while 5 has already been divided into 1. So now we have remaining 2 on the queue waiting for us to attend to it. Now how do we attend to 2? We have to look for a number that can divide 2. What can divide 2? Let's choose 2, because 2 is also a prime number, and as such a prime number can only be divided by 1 and itself. So that means we'll choose itself in this case. 2 in 2 will give us 1. 2 in 1, 2 divided 1, we'll still write 1, that will be 1. So this is the method. This is a simple method if you want to look for the LCM of a fraction. You don't have to follow this process every time, because at times some equations contain denominators that are quite familiar and easy. So in this case, if you get used to mathematics, you can just predict that this will be 10. Your answer should be 10. So but now we've gotten our two terms. Those two numbers that we use to multiply, we are going to multiply those numbers together. Now with 5 times 2 will give 10, and that will be our lowest common multiple. Now this step might look too elaborate and too simple and too simplified, but I'm doing this for those of you who are trying to start out mathematics in high school or secondary school, so that I'm trying to put everything in step by step, so that as I proceed with this course, you can begin to follow me. So there's no essence of me teaching something you will not be able to follow. So I guess you understand. And for those of you who know this method and who think I'm wasting time, you can forward this video. But I believe that everything is step by step. Now when you have your LCM, the first thing you do is you take the first number of the LCM, the first denominator, and you divide your LCM by the first denominator. Now that will be 10 divided by 5, that will be 2, right? Now having this 2, we'll put it on one side, we'll hold on to the 2 in our random access memory in our head. Now we are going to multiply the denominator of that denominator. That's the number above the denominator, which is 2 here. We'll multiply it by that 2, that will give us 4. Then we'll put the sign again, minus. That's the sign connecting the fractions, minus in the middle. Then we'll look at the second denominator again. You are going to divide the LCM by the second denominator. That will be 10 divided by 2. That will be 5. Then you look for the numerator of the second fraction, that's 3, and multiply by your answer. So 10 divided by 2, 5. 5 times the numerator, that's 5 times 3. 5 times 3 is 15. So we have 15 here. Now 4 minus 15, the bigger number has a negative, right? So our answer will be negative. Now 4 minus 15 is minus 11 over 10. Now that is where we stop for this simplification, and you can express your answer in different forms. For example, this minus 11 over 10, you can divide your numerator by your denominator to get a whole number, and then you write your remainder as a fraction. So what I mean is, minus 11 divided by 10 is minus 1. Then you have a remainder of 1. Then put over 10. So this is a negative fraction, minus 1 over 1 over 10. So and in this case, this negative is outside the fraction. So the fraction is in a bracket and the negative is outside it. So you don't have the negative on only one and only the whole number. You have the negative on every part of the fraction. So that's why I put them in brackets. So mathematics is simple if you can take it step by step, understand it, and follow the rules. Now, I'll give an example of solving equations with fractions. Let's solve equations with fractions now. Now, in our equations with fractions, let me give an example. 3 over 4x minus 1 whole number 2 over 3. 3 over 4x minus 1 whole number 2 over 3 equals 2 over 3x. So we have 3 over 4x minus 1 whole number 2 over 3 equals 2 over 3x. Now in this fraction, what we are going to do first, in any time you have an equation with fraction, the first thing you are supposed to do is you are supposed to clear out your denominator. So, and what that means is that you are going to clear out the fractions. That denominator is what makes it a fraction, and the denominator is simply a number that is below. The number above is a fraction. A fraction consists of two numbers, one above, one below. 3 over 5. 3 is the numerator and 5 is the denominator. 3 over 4. 3 is the numerator and 4 is the denominator. 2 over 3. 2 is the numerator and 3 is the denominator. So that is how you identify a fraction. And in this case, this is called a proper fraction. This is called a proper fraction. And then these ones that have a whole number before the fraction are called mixed fraction. And then when you have the numerator greater than the denominator, it's called an improper fraction. Now, you can easily understand that by comparing it to when you have a heavy person being carried by a smaller person. So it looks improper, right? The smaller person is supposed to be carried by the heavy person. So a proper fraction is one that has a smaller number being carried by a bigger number. Why an improper fraction is one that has a bigger number being carried by a smaller number. That seems like a very funny. Now let's clear the denominators in this fraction. The first thing we are going to do here though is we are not just going to clear, because here we have a mixed fraction, so we have to change the mixed fraction into improper fraction. So we write the first one, 3 over 4x minus. Now we want to change this improper fraction to mixed fraction. What you do is you multiply the denominator by your whole number. So you multiply your denominator by your whole number. That's 3 by 1, that's 3. Then you add your numerator to your answer. Now that will be 3 times the whole number plus 2. That's 3 times 1, that's 3. 3 plus 2, 5. So that will be your new numerator. Then you divide again by your old denominator, 5 over 3 equals 2 over 3x. Now we have the numerator, you have the fractions both improper and proper. Now there are no mixed fractions anymore. So now we can now go on to the next step, which is to multiply every fraction by the lowest common multiple. And you look for the lowest common multiple of 4, 3, and 3. Now you use the step I described earlier, but when you use it, try it and then pause this video and try it. Then when you've done so, you can continue. But I've gotten the LCM on my own, and the LCM of this 3 over 4x minus 5 over 3x is equals 2 over 3x. The LCM is 12. So I want to multiply through. So say, write it, multiply 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 through by 12. So multiply by 12. 12 times 3 over 4x. So we'll put it in brackets to show that we are multiplying every term in the bracket. That's why I'm multiplying the fraction as a whole by that coefficient. Minus 12 open bracket 5 over 3 close bracket equals 12 open bracket 2 over 3x. Now we've taken it step by step. The next stage now is to simplify. So now we are going to cut through, because if 4 can go in 4, then 4 should go in 12. That will be 3 times. So we now have 3 times 3x, that will be 9x. Now we'll go to the second one. We want to cut through, so we'll cut 3 and 3, 1, 3 and 12, 4. But if 12 cannot be divided by 4, you leave it like that and you write your answer. But now since they are divisible, we have a quotient of 4. So our quotient is the number that is your results when you divide. After dividing, you get a number called a quotient. Now you multiply your quotient by your number inside your bracket. That is 4 times 12, that's minus 20 equals. Now we'll go to the third one. You cut the fraction down. 3 in 3, 1, 3 in 12, 4. 4 times 2, that's 8x. Now, having made it to this stage, we'll go on to the next stage, which is to collect like terms. Now, this collecting like terms, we are going to look at the left hand side of the equation and look at the right hand side of the equation. In the left hand side of the equation, we have unlike terms. So we are going to collect the unknowns. That is, collect these ones having x onto the left hand side. Then we are going to collect the knowns onto the right hand side. Now in this case, the unknowns here are 9x and 8x. So collect them both to the left hand side of the equation. That will be 9x. When we collect 8x to the left hand side of the equation, it becomes a negative now. That becomes minus 8x equals, then this 20 minus 20 is a constant, right? So it's not like your variable. So we collect the variable in this question. We collect our variable. We collect our constant to the right hand side of the equation. So our constant is minus 20. When we collect it to the right hand side, it changes to plus 20. Plus 20. You can also remove your plus and simply write 20. Plus is a nonchalant sign. So now in this case now we are going to simplify. So 9x minus 8x, you simply subtract the coefficients. That will be 9 minus 8, that's 1. So you add your variable, that's x, 1x. So in mathematics, whenever you have anything like this 1x, you can simply remove the coefficient and simply write x. But we are not going to bother about that. 1x is equals to plus 20. So you can remove the 1 and remove the plus and simply say x equals 20. So in this question, that is the solution. Now, I didn't show you this before, but in mathematics you can always check your answer whether it's correct. So let's check that now. We are going to check if when we substitute 20 for x, we are going to get this. Well, the equation is going to be valid. So that will be our next step. We'll do that in another stage of this video. But whenever you have stuff in your mathematics, you can always check. Now let's check. Let's substitute back. The next step I will teach you soon is substitution. Now, but let me give you a snippet of how it works. Now, in substitution, you are going to replace all your variables, all your unknown, by your answer. So you said x is 20, right? So that means if we replace x by 20 in our initial equation, our equation should be valid only if we solved our equation correctly. So that means if you substitute, also known as if you check, you are going to get your equations valid if you solved it correctly. So let's check that. Now 3 over 4. Now instead of writing x, let's write 20. 3 over 4 times 20 equals, now this is a constant. Let's just write it, convert it to mixed fraction. Yeah, that's 5 over 3. 3 over 20 minus 5 over 3 equals, that's 2 over 3 times x becomes 2 over 3 times 20. And the reason is that x is 20. So now we're going to cut 4 in 4, 1. 4 in 20 is 5. 3 times 5 is 15 equals 5 minus 5 over 15 minus 5 over 3 equals 20. 2 over 3 times 20, that's 3. So it cannot be cut, so we leave it like that. We multiply our numerator. 2 times 20, that's 40 over 3. So is it true that 15 minus 5 over 3 will equals 40 over 3? So let's check our left hand side of the equation. 15 minus 5 over 3 must give us 40 over 3 if we solve this correctly. So checking the left hand side is equals to 15 minus 5 over 3. Now 15 over 1 minus 5 over 3. That would be, we collect the LCM again, that would be 3. How many times can you see 1 in 3? That would be 3 times. 3 times 15, that's 45. Minus 3 in 3, that's 1. 1 times 5 is 5. So 40 minus 5 is 45 minus 5 is 40 all over 3. That's our left hand side. Then our right hand side is what? 40 over 3. So our equations told us that 3 over 4x minus 1 over 2 over 3 will equal 2 over 3x. And when we solve, you can see that this is actually equals to this. Left hand side is 40 over 3x and right hand side is also equals to 40 over 3x. So in this process, I've done two things. I've checked the fact that our equation is correct, and I've done that by using a new method known as substitution. So substitution is basically replacing your variable by your new answer, and then you solve your equation and check if your conditions are correct or are satisfied. Your checking is very useful whenever you are solving mathematical equations that involve long terms or that involves complicated steps. So you can check and then correct your mistakes in case any of them are present. Now I hope you are enjoying this video, and if you are, you can just check below and subscribe. You can share this video, you can like this video, and doing so you can encourage me to continue posting content like this into our community so that we can continue learning. Moving on to the next process, let's go to the next algebraic process. is solving equations from word problems. Now, what's a word problem? A word problem is basically it's kind of like a confluence between mathematics and English. A word problem is basically that question that involves words but is actually a mathematical equation. So let's do that. Let's give an example. So there are various techniques you can use to solve word problems. Well, let me start from the simplest techniques of solving word problems. Now, the simplest technique for you to do is to interpret the question. So whenever you have an equation in a word problem, you interpret the question. Let me give an example. A man walks for 2 hours at a certain speed. He then cycles, that's he rides a bicycle at 3 times the speed for 4 hours. He goes 77 kilometers altogether. Find the speed at which he walks. Now, reading that again, a man walks for 2 hours at a certain speed. He cycles at 3 times that speed for 4 hours. And then he goes 77 kilometers altogether. Find the speed at which he walks. Now, in this question, we are going to interpret the sentences step by step. Now, in the first sentence, we have a man walks for 2 hours at a certain speed. Now, in mathematics, when your questionnaires do not want you to know what the unknown is, they call it certain speed, they call it particular. They won't tell you the particular constant that speed is equals to, or they won't tell you the magnitude. So because it says certain, we are going to represent it as a variable because we don't know what it is. So it cycles for 2 hours, but we know its time as 2 hours. So just simply say t for time equals 2 hours. Now, what is our speed? We don't know our speed, right? But they said a certain speed. So let's say speed. Let's call speed SPEED. Speed is equals to, let's call it s. So let's call the speed s. Now say it cycles, this is second sentence, it cycles at 3 times that speed for 4 hours. So if it cycles at 3 times that speed, that would be the new speed will be speed, let's call it speed 2 equals 3 times that speed. What is that speed? S. So 3 times s is our new speed. 3 times s is 3s. So the new speed is 3s. Then I said it goes at the new speed for 4 hours. So it cycles at this speed for how many hours? 4 hours. So the new time t2, the second time is 4 hours. Finally, they say it goes 77 kilometers altogether. So now what they are trying to say that is that now at the first instance he spent 2 hours cycling at a particular speed. Then he spent 4 hours cycling at another speed, which is 3 times the initial speed, and then it goes 77 kilometers altogether. What that means is that when you add the distance gone for the first condition with the distance gone for the second condition, you are going to get 77 in total. So that means your total distance d is equal to the distance of the first condition, let's call it d1, plus the distance for the second condition, that will be d2, and that will give us 77 kilometer. Now, what is the distance for the first condition? In mathematics, there's an equation for distance, and distance is known as distance is equals to the time multiplied by the speed. And what that means is that distance is the product of the time taken for a journey together with the speed at which that journey is carried out. So the distance here will be t1 times s1, that's 2 hours. T is 2 hours times, let's just put the magnitude because what we are concerned here is the magnitude. 2 times, let's put it in brackets, 2 times, distance one is speed times speed, that's 2 times speed, which is s, we don't know what it is, 2s plus, in the second instance, time times speed is what? 3s times 4, that's 3s times 4. Then when we add everything to give us 77. So I've discarded the unit and I've included just the constant. Now in the first case, 2 times s is 2s plus, in the second case, 3s times 4 is 12s. So 2s plus f12s give us 77. Now good, we've gotten so far. Now let's move on to the next part of the question, which says we are going to simplify it. So now we already have the unknown terms on the left hand side, so we don't need to collect any like terms anymore. So what we need to do is just simplify. In the left hand side, we are going to add the variables. That will be 2s plus 12s, that will give 14s equals 77. Now we'll now move on to the last stage of simplifying this equation, which is to divide both sides by the coefficient of our variable. That's divided by 14, divided by 14. So 14 cancels 14 out, and then we leave s, which is our variable, and then we have in the right hand side we are going to simplify the constant. 77 divided by 14. Let's see, can we cut it down? We can cut it by 7. Dividing both sides by dividing numerator and denominator by 7. 7 in 14 will give 2. 7 in 77 will give 11. So we have a new fraction, which is an equivalent fraction that has been cut down. That will be 11 over 2. So and then we can still convert this into improper fraction. 11 over 2 will give 2 in 11 is 5. Remainder 1 over 2. That's 5 whole number 1 over 2 what? Kilometers. So in your final answer, you include your units. But when you are doing your processes, in order not to get confused, and in order for the equation not to get bugged up, you should remove your units and include them at the final. I remember when I used to take further mathematics, which is advanced mathematics classes in high school or secondary school, and I used to deal with equations that often cover like 3 pages or 2 pages. And in those cases, what we do is basically you leave out your units, you leave out every unit, and you just deal with the constants, and then you make your work as neat as possible. So that's just a tip for you in case you are already solving this kind of equations, and in case you are looking for how to make your work neater and more presentable. Now that was the fourth method of solving equations. I don't know, fourth or fifth, and that is the method of solving for word problems. Now I hope you understood that method, and now let's move on to the next method, which is substitution. I talked about substitution in a little bit of as a snippet in the earlier examples of this video. Now let's address it in full detail. Now when you are talking about the method of substitution, what you are going to do is you are going to replace your unknown by your knowns. So let's do that. Now the next method of algebraic expressions and equations, when you want to simplify and make them easier in mathematics, the next method is substitution. Now in this method of substitution, we are going to replace our unknown by the numbers or constants assigned to them. So simply, substitution is just the process of replacing unknowns by the constants assigned to them. Now let me give an example. Use the formula A is equal to half base times height to calculate the area of a triangle, given that the base is 3.2 centimeter and the height is 5 centimeter. Now let's write out the formula. A equals half base times height. So this is how it is written. And then given that the base is 3.2 centimeter and the height is 5 centimeter. So what I'm trying to say is that base B is 3.2 centimeter and our height H is equals to 5 centimeter. So what we're going to do is simply use this method of substitution. You don't need to collect like terms anymore. You don't need to expand. You don't need to open your brackets. You don't need to simplify first. The first thing you do when you see an equation like this is to substitute your variables by the constants assigned to them. So 3.2 has been assigned to B and 5 has been assigned to H. So instead of B and H, we'll simply replace them by 3.2 and 5 respectively. So that means our area will be equal to half. What's the base? The base is 3.2. Half times 3.2 times the height is 5 times 5. That will be 1 over 2. 1 over 2 times 3.2. So now we can multiply 3.2 by 5. That's 3.2 times 5. That will give us 5 times 2, 10. 0, write your 0, carry a 1 to the unit place value. 5 times 3, 15. 15 plus 1, that's 16. 16.0. So we have 16.0 as our area. So let's write area is 16.0 divided by 2 as the denominator. So area is 16.0 over 2. Now 16.0 over 2 will simply be 8.0. 8.0. Then we'll put our unit. The unit of area is centimeter squared. So our area is 8.0 centimeter squared. So that is how you solve substitution. Now, if you are still here watching, let me give you one as a classwork, so you can try that out. Try finding the area using the same formula. Try the area, but when the base is 4 kilometer and the height is 600 meter. That isn't difficult. So using the same formula, try the base as 4 kilometer and the height as 600 meter. So you can pause the video and try that using a base of 4 kilometer and a height of 600 meter. So you are going to express your answers in kilometer. So find the area in kilometer. So pause this video and then try it. So I will work it down here. So the area in this case is still half base times height, but then you are using the base as what? Half. The base is now on 4 kilometer. 4 kilometer, let's put it 4 times 600 meter. So we are write 600 meter and divide by the conversion factor, right, which is 1000. The reason why we divide by 1000 is that 1000 meters make 1 kilometer. So we divide by 1000. Then we cancel the zeros out. 0, 0. 6 over 10, that simplifies to 3 over 5. Then now we'll simplify our fraction by multiplying the numerators by the denominators. So our area becomes 4 times 3. So first of all, we can still cut it down. 2 into 1, 2 in 14. Right? Sorry, 2 in 4. The base is 4, 2 in 4, that's 2. So now we have 2 times 3 is 6, all over, the base is 5. All over 5. That's 2 times 3 is 6 over 5. So we can convert to improper fraction as 1 whole number, 1 over 5. And then we can still convert to decimal as 1.2 kilometer squared, which is our new area. So I must say that our area is actually large in this case. So magnitude is another thing you must consider in mathematics. Now that is the method of simplification. If you got it correct, you can clap for yourself. Let me do that for you. Now moving on. The last method we'll be talking about in this video today is the method of change of subject or formula. Now the method of change of subject or formula just involves when you collect your like terms. So in order to change the subject or formula, just solve for the equation which you want to make your subject, and then after making your subject, you simplify. So let's do that. So we are going to use the method of change of subject or formula. So in this question, let me give an example. Make x the subject of the formula a is equal to b open bracket 1 minus x close the bracket. That will be a is equal to b open bracket 1 minus x close the bracket. So what is this trying to tell us is that our a is b multiplied by 1 minus x. Now we are going to open the bracket in the first instance. So this is a combination of different methods. This is a combination of equation on brackets with solving algebraic equations, and then using the method of change of subject. So we are going to take it step by step. The first thing in any equation that has brackets is to open the bracket or to remove the bracket, and you do that by simplifying the bracket by carrying the algebraic process of the coefficient of the bracket. So the coefficient of the bracket here is b, right? We are going to multiply the bracket by b, and that coefficient will be multiplied by every term in the bracket. So that will be a equals b times 1 is b, b times minus x is minus bx. Now having done that, we will need to collect the like terms. So now we have a is equal to b minus bx. So we can move b to the left hand side of the equation. That will be a minus b is equal to minus bx. So we've gotten so far, and then the next thing we'll do is we'll divide both sides by the coefficient of x. That will divide side by minus b, divide both sides by minus b. So a coefficient can be negative or positive. Now dividing both sides by minus b cancels out. That will equals x equals to a over a minus b over minus b. So now your negative can also come up as minus a minus b over b. You can also express it as this, but that will still be your x. So this is our answer, and this signifies the end of our video today. I will give examples and you solve them. Now let me give you one example before we end this video. So make x the subject of the formula a is equal to b plus x over b minus x. So that in this we are making a is equal to b plus x over b minus x. Now let's see if you can solve this equation, and then I will attend to it in the next episode. Thank you for watching.